there, welcome back to our channel where we unravel the mysteries of programming. Today we are diving deep into the fascinating world of C++ and a concept that might sound a bit complex, but don't need to fear. We are talking about constexpr. If you're a student or newbie coder, you are in for a treat. Let's empower your code with compile time magic. So, so before we get started, make sure you have got your coding hats on and where we are going to going to explore the incredible powers of constexpr in C++. So first things first. So what is constexpr? Well, it's short of a constant expression. Imagine being able to calculate things at compile time, making your program super efficient. Constexpr turns the impossible into reality. So we will be seeing a simple examples of constexpr. So as you can see from the in the editor, Visual Studio Editor, it's a Fibonacci API. It's a recursive API which calculates the nth Fibonacci number from the start. I'm calling this Fibonacci API from the main API and passing the number 5. Means I want to get the fifth Fibonacci value. For this API looks fine and we will get the desired output if we try to run this particular code, as you can see from the output window. So let's try to comment out this exit condition of this recursive function. So then when you try to run this particular code, it will throw an exception. It will be mainly stack overflow exception since since the exit condition we have commented out, and there will be infinite number of recursive call which will be made in this particular API. So we are able to catch this particular exception only during the runtime. So think about a situation if you are able to catch this particular exception in the compilation phase itself, wouldn't it be more powerful? Yes, there is a way to catch this particular exception during the compilation phase itself. There comes the importance of constexpr. Now let's make this API constexpr. And also we have to make this particular return variables also constexpr since we are returning a constant value. So now this function is a constexpr function. Let's try to comment out this exit condition. So as soon as we commented out this exit condition, we will get an error. So it is saying that expression not folded to a constant due to excessive constexpr function called complexity. The call complexity is more since there is a recursive call happening multiple times. So this expression execution is trying to execute during the compilation phase itself. That is why it is able to catch that it is an infinite recursion which is happening, and it is not able to compute the constant value or get a constant value out. So here we are able to catch it during the compilation phase itself. So the main advantage of constexpr is it speeds up your code execution, and there will be memory usage will be much more optimized since we are dealing with constant values, etc. And this error checking at compile time, which we now saw, means we are able to detect that infinite recursive call during the compilation phase itself. Any advanced constexpr topics that you need to know, I have made a comprehensive series of blog posts on constexpr, which will be there in this particular link. Therefore, I will just paste this link in the description box below. Do check out the description box. So the first blog post actually explains what is constexpr and basic things about constexpr with a comprehensive list of examples. The second blog actually talks about the if constexpr expression, which is used for branching, conditional branching. And the third blog post deals with the best practices for using C++ constexpr. So do check out this blog post, which I am posting in the description box below, to get much more insight into this constexpr. So that's a wrap from my side. We have tamed the wild beast that is constexpr, and now you are armed with the knowledge to write supercharged C++ code. So smash that like button, subscribe for more coding adventures, and remember the compiler is your ally. Until next time, keep coding, keep learning, and keep pushing those boundaries. Happy coding, and I will catch you in the next video. Thank you.